And welcome back. So we're going to talk about isotopes and ions. There are three small learning targets attached to these. The first is to define those terms and then properly use and interpret a symbol for an isotope, and then understand and explain the formation of ions and how to name them properly. So here we go. So, isotopes. They're atoms with the same number of protons but different numbers of neutrons. Remember, protons are the identity of an atom. That is the number of, if we change the number of protons, we get an entirely different atom. And so, isotopes have the same number of protons, but now we're changing the number of neutrons. That means that we're changing the mass of the atom, but not its identity and not its chemical properties. And so isotopes are almost identical with their chemical properties um, because those chemical properties are due to electrons. And in nature, most elements contain a mixture of isotopes. And so there is usually a predominant isotope, which is what skews the atomic mass of the average atomic mass of an atom. But then there's other isotopes that can uh, change that mass um, higher or lower than the predominant isotopes. And we'll do a lab where we kind of look at how the average atomic mass of an atom is weighted based on the percentage of isotopes. And so here are two isotopes of sodium. You'll notice that the nucleus is what's changing. One isotope has 12 neutrons, one has 13. That means the mass number is changing. And we'll kind of break down the symbol of an isotope here in the next slides. Number of electrons is remaining the same. So isotopes are written in symbolic form. And so this kind of breaks it down. X is the chemical symbol. That's what you get off the periodic table, either one or two letters. The A represents the sum of the mass. That is protons plus neutrons. And so if this was 14, that means that 14 is made up of X number of protons and Y number of neutrons. The Z is the atomic number. That is what you get right off the periodic table. That is the number of protons. And so you use these two pieces to determine the number of electrons or how the mass number is changing. So here's an example. Here's carbon 14 and carbon 12. These are two isotopes of carbon. C is the same because it's carbon. The number of protons is the same because carbon has 6 protons, but the mass number changes because we have more neutrons in carbon 14 than we do in carbon 12. In this, I intended for you to answer without the answer there, but there it is. So we have an isotope. It has 23 protons and 28 neutrons. I can add these two together to get the mass number, which is 51, and then I identify the element based off the protons. So this would be vanadium. Excuse the cough. The next piece is ions. So protons, when we change the protons, we change the identity. When we change the neutrons, we change the mass number. When we change the electrons, we change whether or not we have ions. And so atoms can form these ions by gaining or losing electrons from their outermost shell. So if you think of Bohr's model and the rings, the electrons that are on the outermost ring are the ones that are going to either be gained or lost. Again, I am so sorry for the coughing. So metals tend to lose. It's easier for them to lose electrons than to gain. And so when they lose electrons, they form positive cations. And so here's magnesium. Magnesium is a metal. It prefers to lose. And so we have 10 electrons. It loses 2. And that means magnesium is going to have a +2 charge because it lost 2 electrons. And so that balance has been shifted into the positive direction. Cations generally are named just by calling it the parent name. So this would be magnesium ion and not magnesium. That's how I know that I've lost electrons, because I use the word ion after the name. Nonmetals do the opposite. They tend to gain electrons, and they form negative ions called anions. So when they gain electrons, the atom actually gets a little bit bigger. And so here's chlorine. Chlorine is gaining an electron, and so the nucleus stays the same, but the electron cloud gets bigger, and I have a negative ion now. So anions, when we name those, we actually take the ending of the name off and add "ide." So we use the root "I" or the suffix "ide," and then ion. So this is a chloride ion. If this was carbon and it was negative, it would be a carbide ion. Okay. And so we will go over this in class. So this is just counting subatomic particles. Thank you for joining this quick lesson, and until next time.